Up next, we have a keynote from our expert in residence, Dr. Serge Belongie, whom you've already met. And if you've just tuned in, Serge is a professor of computer science at the University of Copenhagen, the head of the Danish Pioneer Centre for Artificial Intelligence. His keynote is titled Computer Vision and Machine Learning Trends from Autoregressive Token Prediction to Agentic AI, Physics Engines, and much more. Take it away, Serge.
Great, thank you. So you've heard these terms. Actually, it's a great segue. You just heard about large language models, and what I'd like to do is just take a quick look at what's going on in generative AI, state of the art, what works, what doesn't work. So let's just start with the table stakes. What do you need to get into the game with large models, large language models, large vision models? One thing that you're going to see in a lot of these applications is language models that are trained based on masking. So you've probably heard about BERT. And in that case, what you're dealing with is tokens that in this case are words. And what you're doing in these cases is just erasing words and training large neural networks to fill them back in. So your intelligence, such as it is based on your ability to predict tokens that are missing. In the context of images, instead of erasing tokens that are words, you're erasing patches of pixels. And you have a variety of tasks that implement this masking. It could be scrambling, it could be removing the color, and you train neural nets to fill in the things that were masked. So this is what has given rise to this modern kind of ChatGPT revolution of generative AI, is this so-called representation that's learned, and it's able to predict the next token. So we all type in prompts into our chatbots, and we have these very powerful representations that look at the sequences of tokens, and they tell us tokens that come next. And it's very human-like, it's very lifelike, but at the same time, as you just heard in the previous discussion, it's prone to hallucination. The other kind of thing that you'll hear a lot about is diffusion models. In the context of diffusion models, one way to think about it is if the large language models that we just saw are next token prediction, the diffusion models are next noise prediction. So they make use of a different type of masking. Instead of eliminating tokens and filling them back in, what you do is add noise and figure out or learn how to counteract that noise. How do you add patterns to get rid of noise, to take this diffusion process backwards and eventually denoise something into a desired appearance of an object or a scene based on text and image embeddings. So this is what gave rise to the very photorealistic approaches that we've been seeing in recent years. And in fact, the modern approaches you see are often a combination of next token prediction and next noise prediction. So these are very powerful methods, but again, they are prone to some kind of hallucinations or confabulations. And when this occurs, you need some way to steer them or control them. So they're very fluent in what they do, but they're not necessarily doing exactly what you want to do, or you want to fact check them. That's where the concept of retrieval augmentation comes in. You've heard of this in the case of RAG, for example, retrieval augmented generation. In the context of text, you have a large amount of documents that are hot off the presses, saved on your local computer, and you would like your generated responses to take that into account and actually make specific reference to real journal articles or to stylistic transfer that you want to make to an image while preserving the content. All of that is happening through retrieval augmentation. So you've got that large language or large vision model that's like the smarts or the fluency of the system, and then it's augmented with things that are retrieved on the fly. So that's responding to the fact that these very eager and kind of fluent large models need to be steered. But then we get to this current revolution of agentic AI. And in this context, it's really about the devil in the details. So when you've got something like a large language model and you're combining it with retrieval augmented generation, then you start getting into the weeds of the many, many tasks that are needed in enterprise settings or research labs. And what we find is that there is no silver bullet. There's no single AGI that solves all of these problems. And so what we have is the traditional software engineering approaches or some kind of app store that's solving all of these things inside little silos. Finally, there is the world of embedded or embodied AI. If we really want to talk about planning and reasoning with these systems, text and passive video is simply not enough. And that's what brings us to these recent advances like the Genesis team that makes the physics simulations, or what Jan talked about from NVIDIA with robotic simulations. You really need to have these systems or the agents in these simulations interacting with physical scenes. This is something that can't be captured just from tokens and text and passive video consumption. So if we want to move toward actual planning and reasoning, then it will be very important to have increasingly photorealistic and physically realistic settings. So to wrap up, these large multimodal models, language or vision, are of course very powerful, and they give these systems fluency and the appearance and trappings of intelligence, but they need a lot of hand-holding and steering. You can get some of that through the retrieval augmentation pipeline. You can get some of that through the agentic traditional software engineering framework, but whatever happens, you need to steer it. You need to control it to get it to work in a practical way. And finally, if we're to move toward the robotic implementations of these systems, we're going to need ever increasing realism in the physics simulations. And with that, I will stop, and there's a URL for the Pioneer Center where I work if anybody wants to look into that. Thank you.